We join our lesson, already in progress.
Okay, so it's possible for the tangent or the cotangent function to have a coefficient that's negative. It's a negative on the outside of the function. What it means is that the guideline graph is also negative, and that both f of x and g of x are reflected about the x-axis. Now, zeros and asymptotes are unaffected by this reflection. However, the positive one and the negative one are affected. This changes the direction of the branch. For example, here, f of x equals negative tangent x. G of x is negative cosine x. And you can see it actually starts below the x-axis when we draw it from 0 to 2 pi. And so the cosine function has been reflected about the x-axis. It turns out that so too is the tangent function reflected about the x-axis. It is now a decreasing function, where before it was increasing. Let me show you what the positive tangent function looks like here in red. And you can see that the function in black has been reflected about the x-axis. Let's do the same for negative cotangent x. G of x is negative sine x. Sine starts at 0 and goes down to negative 1 before it continues on its way to 2 pi. The asymptotes are the same for the cotangent function, but notice that it's drawn in the different direction. In fact, let me go ahead and draw in blue the positive cotangent function. So, let's graph two full branches of f of x equals negative tangent of 1/3 x. G of x is the cosine function, but it's going to be negative cosine of 1/3 x. Is g of x reflected? Yes, because it's negative. The period for g of x is 2 pi divided by 1/3, and that's 2 pi over 1 times 3 over 1, that's 6 pi. So let's locate 6 pi on the x-axis, and we'll find halfway. Half of that is 3 pi. Find halfway again, that's 3 pi over 2. That's the quarter period. And then the 3/4 period is 9 pi over 2. We'll go ahead and draw the negative cosine function. That means we start at negative 1, then go to 0, positive 1, 0, negative 1. And we'll lightly draw that graph. Next, let's identify where the cosine function is 0, and we'll draw asymptotes for the tangent function. Of course, this gives us only 2 asymptotes, so we've got to find one more 0, and we'll do so by going to the left on the negative side, to negative 3 pi over 2. So that's another 0 for cosine, and that means another asymptote for tangent. Halfway between each pair of asymptotes is a 0. Between 3 pi over 2 and 9 pi over 2, halfway between that is at 3 pi, and we have a 0 there as well. Then, halfway between a 0 and an asymptote, between 0 and 3 pi over 2, is 3 pi over 4. And we will put that value into the f of x function. F of 3 pi over 4 is negative tangent of 1/3 times 3 pi over 4. The 3's divide out. That's equal to negative tangent of just pi over 4. And that is a negative 1. So at 3 pi over 4, the tangent function is negative 1. We'll put a dot right there. Which means that on the other side, between the 0 and negative 3 pi over 2 asymptote, we have a positive 1. Now we have those 3 points. We're going to come down from the left side asymptote through the 1 up to 0. And that's all concave up. Once we hit the 0, and go through the next 1 at 3 pi over 4, It's concave down all the way to the right side asymptote. And between 3 pi over 2 and 9 pi over 2, we can do the very same graph. Put the positive 1 and the negative 1, and draw the second branch through those points. So what is the period of f of x? It's always half of the period of the guideline function. And g of x has a period of 6 pi, so 1/2 of 6 pi is 3 pi. Does the tangent graph have an amplitude? Well, quickly no. And that's because it's not a wave like the sine and cosine functions are. We could put a coefficient in front of the tangent function or the cotangent function. Here's how it would compare. If we multiplied a tangent function by a number greater than 1, such as 2, in this case, h of x equals 2 times tangent x, it actually makes the graph steeper and more narrow. You can see in quadrant 1 where it's steeper than our standard f of x equals tangent x parent function. And you can also see that 1/2 times tangent x is wider than the parent function. So for our purposes, we're going to leave the coefficient to either be positive 1 or negative 1 and not worry about being narrower or wider. So now we're going to graph two full branches of f of x equals negative cotangent of 3/4 x. Again, we'll identify g of x. In this case, it is negative sine of 3/4 x. And yes, it is reflected. The period is 2 pi over 3/4. That's 2 pi over 1 times 4/3. That becomes 8 pi over 3. So we'll locate the period 8 pi over 3 on the x-axis, and we'll find the halfway point, 4 pi over 3, and half of that is 2 pi over 3. And 3 times that is 6 pi over 3, but that simplifies to 2 pi. Let's place the points now for the sine function. It's a negative sine function, starting at 0 to negative 1 to 0 to positive 1 to 0. And we'll lightly draw in the sine function. Now we'll draw the asymptotes for cotangent by locating the zeros of sine. The first one is on the y-axis, so there's the first asymptote. The next asymptote occurs at 4 pi over 3, and the third at 8 pi over 3. Halfway between each pair of asymptotes, the function is 0. So at 2 pi over 3 and at 2 pi, we have zeros. We have to identify what the value is between the first asymptote and the first 0. That's halfway from 0 to 2 pi over 3, which is 1 pi over 3, pi over 3, and we will put pi over 3 into the function f. That gives us negative cotangent of 3/4 times pi over 3. The 3's divide out. That gets us negative cotangent of just pi over 4, and that is negative 1. So at pi over 3, we have negative 1. That also means that the other halfway point between the 0 and the asymptote is a positive 1. And now we can come down from the right side asymptote through positive 1 to the 0. That's all concave up. And then from the 0 through the negative 1 on down to the left side asymptote. And that's all concave downward. And we can duplicate those points for the next branch. And we can duplicate the curve as well. I think you can just look and see what the period for cotangent is. From the first asymptote to the second asymptote is a distance of 4 pi over 3. But we can also find it by taking half of the period for sine. 1/2 of 8 pi over 3 is 4 pi over 3. Okay, now let's graph two full branches of f of x equals tangent of 6/5 x. The denominator for tangent is cosine. So g of x equals cosine of 6/5 x. G of x is not reflected, so no. And the period for g of x is 2 pi divided by 6/5. That's 2 pi over 1 times 5/6. And we can simplify the 2 and the 6 to get 1 and 3, and that becomes 5 pi over 3. So let's locate 5 pi over 3 on the x-axis. Then we'll take half of that value. That would be 5 pi over 6. Half again, 5 pi over 12. And now we'll multiply that by 3 to find the 3/4 period. Let's do that up above here. 3 times 5 pi over 12 is 5 pi over 4. The 3 and the 12 simplify a little bit. So we get 5 pi over 4 at the 3/4 mark. Okay, so let's draw in the cosine function, and it's not reflected, so it starts at 1, goes to 0, -1, 0, and +1. And we can lightly draw that graph in. The zeros are at 5 pi over 12 and 5 pi over 4, so that's where we have our asymptotes for tangent. And we need one more asymptote, so we'll draw a little bit to the left over to -5 pi over 12. It's another 0 for cosine, and it's another asymptote for tangent. Again, halfway between each pair of asymptotes is a 0. So a 0 at the origin and a 0 at 5 pi over 6. We now want to identify between the first 0 and the first asymptote at 5 pi over 12. Halfway there is 5 pi over 24. So we'll put that into f. F of 5 pi over 24 is tangent of 6/5 times 5 pi over 24. Now the 5's can divide out, and we can divide 6 out of the 6 and the 24 to get 1 over 4, and that gives us tangent of pi over 4, which is +1. So at 5 pi over 24, tangent is +1. And that means halfway on the other side, we get a -1. And now we can draw our graph. Tangent comes down from the right side asymptote through 1 to 0, and then through -1 to the left side asymptote. The next branch between 5 pi over 12 and 5 pi over 4 is exactly the same. We just need to plot points for the 1 and for the -1, and then draw the graph. Well, I hope this has been helpful to you. I know I had fun. See you next time. Bye-bye.